Containerize web application from on-premises to EC2. In this video, we will explore our third option to migrate our web application from on-premises to EC2 using the VM import feature. And with VM import, we can export specific types of operating systems from our local hypervisor, such as VMware ESX, VMware Workstation, Hyper-V, and use the VM import function to migrate it to EC2. And this is a list for the operating system that are currently supported by the VM import feature. So there is a big list of supported systems, but this is the limitation that you have to keep in mind. In our case, we are using Ubuntu 18.04, so this is a supported version that we can use the VM Import API to convert it into EC2 supported instance. So our plan for containerizing our web application from our local hypervisor to EC2, first we need to prepare our image, and this consists of a few steps. First, we need to remove the OpenVM tools. This is usually installed on VMware environment and can cause issues on EC2 if you are running it in the cloud. So first we need to remove this package, and we can also remove our CD-ROM driver. This is also known to cause issue, and it's recommended to remove it. And next we need to shut down our machine, and in our case we will export our image to OpenVM file. And we can also use OVA files to contain multiple disks or support multiple disks. But you can also use a VMDK file directly or virtual hard disk. And finally, we can take these files that we exported and upload it to AWS S3. And if you're not familiar with the S3 platform, this is a storage service provided by AWS. We're just going to use it as a storage to upload our image files. And next we need to install AWS CLI. This is a tool that allows us to programmatically access our AWS services and do all kinds of different services from the CLI. This is also available for Windows, Linux, and Mac, so you don't have an issue finding it for your system. And the last step for us to be able to interact with the VM import, we will need different access levels created for this to work. So first we need to create an IAM user. This is an identity and access management user, so we can have access to AWS CLI. And we also need to create a service rule and policy attached to it. And to simplify this process, I have included all the JSON files that are needed for this step, building the service rule and policy. And finally, the VM import manifest, which just contains our file that we uploaded to S3. And finally, we can run the function and see how it works. And the way we can remove the open-VM tools, we can do sudo dpackage to remove this tool and leave the dependencies behind so we don't cause other issues. And now we can go ahead and modify our virtual machine to remove the CD-ROM as well by removing these two drivers. It may also be a good idea to remove the floppy driver because I don't believe we're gonna need this. And now we have our virtual machine ready for export. So the way you can do it from VMware Workstation or ESX, you can just click File and Export to OVF. And this process will take a few minutes to finish, and then we will have an OVA file ready for our image to be uploaded to Amazon S3. And once our export has finished, now we can go into S3. This is where we can upload our file. And first we need to create a bucket, and bucket in S3 is like a folder, and we can store our OVA, VMDK, or VHD files in this bucket. We can just call this Server Migration 101. This name has to be unique because it uses the global DNS system for the S3 domain. And the region for the bucket has to match the same region where we want to deploy our image. So if you want to deploy your image in North Virginia, you want to use North Virginia region. In both EC2 and the S3 bucket. And we can go ahead and create our bucket. And from here, we can upload our two files. First, our OVF file and also the disk file. And as the upload is going through, we can prepare our identity and access management user so we can access our AWS CLI by going into our identity and access management console. We can create our first user. For this, let's just give it a name AWS CLI. And when creating a new user account, you are given a choice between giving access to the management console, which is this GUI we are using in here, or we can just enable programmatic access. We can have access to things like API, CLI, and AWS SDK. So we just need the programmatic access to get this to work. And we can temporarily give this user admin access. We can optionally add tags as well, so we can easily manage multiple users. And finally, we can create our user account. And once our user has been created, we will be given access key ID and a secret access key. Those are like a username and a password. So assuming you installed AWS CLI on your operating system already, all we need to do right now is to configure our AWS CLI parameters to use this access key ID and secret access key. So starting from our command prompt, we can first configure our parameters using AWS configure. And once we put AWS configure, we will be asked for our AWS access key ID. So we can copy this access key ID and this will be our access key. And for the password, we can only see this once, so we can copy this and save it in here. And for the region, as we have used already US East 1 to host our S3 files and planning to use EC2 on this region, so we can keep using US East 1 inside our AWS CLI. And we can finalize our setup, and now we have our parameters ready. So now we are ready to go ahead and start creating our service rule. And the service rule file is called iam-rule.json. And this would allow our service rule to have access to the VM IE. This is the VM import feature. So we can create our service rule using this JSON file by doing this command AWS IAM create rule. And this will assign our rule name of VM import. And we'll give it assume rule based on iam-rule.json. So in here, you have to define the full location to get to your iam-rule JSON, which is attached to this class. And once you hit enter, this will communicate with the AWS CLI to try to create this service rule for us so we can proceed with our setup. And in just a few seconds, it will send us this return answer. And once we see a rule ID and ARN ID, now we know this is a success. We also see a time flag for when this rule was created. So this returns to us the rule that was created with all the parameters. Now our next step is to assign a policy to this rule to allow it access to different services. This will be our iam-rule-policy.json, and this would allow the service rule to have access to S3. This is the service where we uploaded our virtual machine files and virtual disk files. And in here, we have to define the S3 bucket where we uploaded our files. So if we go back to our S3, this is the bucket where we uploaded our VMDK and OVF file. So if we want to get the ARN back from this folder, we can just select our bucket and hit the copy ARN button. And this would just give us a full location for our folder. So we're just going to replace this line with our bucket ARN and also do it one more time in here with the wildcard. We can use the same folder for our export. And in order for us to assign this policy to our service rule, we can use this AWS IAM boot rule policy and define our rule name. It was VM import. This is where we had the last step. And for the policy, we will also call it VM import. And for the policy document, we can point it to this IAM rule-policy JSON file. And once we hit enter, this command took a few seconds and it did not return anything for us. But if we go to our identity and access management rules, we can see that our VM import policy has been attached as inline policy. And if we expand this, we will see our JSON file that confirms we have our ARN for our migration bucket. So this is all we need to do with the identity and access management. Now we are ready to launch our final JSON file. This contains the import manifest. So we just called it import.json. And for this file, we just need simple information like what description to give to our instance. We're just gonna call it broad-WordPress. In here, we define our format. So for OVA file, you would configure to use OVA and point it to our file name and bucket name. So we can verify our file name matches. This is server migration 101. And inside of this, our OVF file is called broad server.ovf. So we can go to our JSON file, need to make sure our file name matches, and we can save our file. And this is what we need to use to import our image. So now we are ready to launch our import process. And for this, the command will be AWS EC2 import image. And for this, we can give it a description. I just called mine broad-WordPress. And then we can give it the manifest to upload. So in this file, we will use the import.json. So it would know which bucket and which S3 key to get access. And once we hit the enter, this will actually start the migration process. And it will return to us some JSON output like this. It would contain our description, our import task ID. This is very important because this is how we can track the progress of this. And we can see that the status right now is active. That means the import is in process. And this process might take a few minutes, but we can always check the status on it by using this command AWS EC2 describe import image task, and we can add the filter import task ID. And for this, we need to define this import task ID. So we can go ahead and check our status. And this will return to us a simple status message like this that says this is still active and it's pending. And unfortunately, for the first time, it did not work. So this is not going through very easily. Now, our last option is to try to use the VMDK file directly. We can just go back to our import.json and change the format to VMDK and point to our VMDK file on our S3 bucket. Save our file. Now let's go for the last time and try to import our file. And now if we check the status on the VMDK file, now it says converting. So we had a better result than using the OVA format. And after half hour or so of waiting, now we see the status is changing to completed for our VMDK file. And the status is changing to preparing to boot. And shortly after, we would get a snapshot ID when checking for our status. So once we see a snapshot ID, that means we already have a snapshot on the system for our image. And this snapshot is used to prepare AMI. And AMI stands for Amazon Image. So for this AMI, we can use to launch any EC2 instance in the future using our containerized server. Now, if we go into our EC2 to check on this snapshot, and we can see the snapshot count has been 1. And we will see here that this was created by AWS VM Import for this import task, and it's already available for use. And this will be used to create an image under AMIs. If we go under AMIs, this would be our AMI ID, and the status on this is available for use. And also, if we come here and check our status, we will see that our status changed to completed. So this is a very lengthy process. but it does work if you have a service on premises that you don't want to redeploy in the cloud. You can simply extract to VMDK file, and it's just a one-time process, even if it were lengthy. But after that, you got your goal, and we have our AMI ready for use. And the way we can launch this, we can simply come here and click our launch button, and we can keep using the free tier image and click next. We will deploy this on our public subnet, and we will assign a public IP address to our instance. And finally, we can review and launch our instance. And we're just gonna create a new key pair for our new instance and then launch. And now our instance has fully launched, and we were given this public IP address, and it also created this default security group. So this usually come with only SSH access. So let's quickly add a new filter in here to allow our web access to our instance. And we will allow them from all internet IPs. And now we can save our rule. And now we can use the public IP to try to access our instance. And we are getting our blog to work on the new EC2 instance that was created using the VM import feature, and it created for us an AMI or an AWS image to be able to spawn EC2 instance in the future. Now, to make sure we are not leaving any security holes behind, we need to make sure that we go back to our identity and access management and make sure to delete our AWS CLI user account, which is in the admins group, because if our machine gets compromised and this user has full access, this account can be used to cause a lot of harm to your AWS account. So make sure you delete or reset the access keys that you no longer use. Even if we were to go back to our AWS CLI and try to run any command that requires connection to AWS, we would get this error for authentication. So now this user is no longer usable. And that's how you use AWS VM Import to containerize and migrate your virtual machine into AWS EC2. Thank you for watching.